In the last video, I've talked about calculating the motion of an hydrogen ion as it moves through this uniform magnetic field. And we found that the hydrogen ion will move around in a circle that has a radius of 1 millimeter. In this video, I'm just going to take this idea a little bit further. Now suppose that instead of a hydrogen ion, let me think of another atom. Let me think of, say, a carbon ion. Now, a carbon ion is heavier. Okay, it's heavier. Presented by C+, meaning a hydrogen atom that has lost an electron. A carbon ion has at the center of the nucleus. I'm trying to represent that. Imagine a carbon. So it has more. It's 1, 2, 3, 4, 5, 6 protons at the center of the nucleus, but it also has 1, 2, 3, 4, 5, 6 neutrons, and then it has got 6. A carbon ion would have maybe just 5. The atom has 6 electrons. 1, 2, 3, 4, 5. The carbon atom has 6 electrons, but the carbon ion has lost 1 electron, so it has just 5 electrons going around the atom. Now the electrons are very light, so at the nucleus, at the center, there would be 6 protons and 6 neutrons. Okay, so these protons and neutrons are roughly the same mass. A proton is roughly as heavy as a neutron. So, or very nearly. Okay, so this means that the carbon ion or carbon atom would be 12 times heavier than a hydrogen atom. Okay, so if the mass of the hydrogen ion is m, given by this value here, the mass of the hydrogen ion is m, mass of the carbon atom must be 12m. Right, the mass carbon ion must be 12m, 12 times of the mass of hydrogen ion. Okay, and indeed, if you look up the periodic table for carbon, you'll find that 12 is the mass number, and the mass number is basically the total number of protons and neutrons. Okay, right. So what I'm going to do is this: instead of shooting a hydrogen ion into this magnetic field with the speed of 10 to the power 5 meters per second, I'm going to change that to a carbon ion, right, which is 12 times heavier, but I'm going to shoot it in at the same speed, at the same 100,000 meters per second speed. And this time I want to calculate the radius for the carbon ion. Because since I'm talking about a carbon atom that has lost just 1 electron, carbon ion has the same charge as the hydrogen ion, so the charge is still the same. It's still 1.6 times 10 to the power minus 19. Okay, the carbon atom itself would have 6 electrons to cancel the charge of the 6 protons, but the carbon ion has just lost 1 electron and it has 5 electrons left, so it will only cancel 5 of the charges of the 6 protons. Okay, so the charge of 1 proton can still show up, and that gives it the same charge as a hydrogen ion. So it has the same charge, but so the only difference quite a big difference, but the only difference is that I'm now using an ion that is 12 times heavier. But the charge is the same, the field is the same, the velocity is the same. So the mass is the only change, and if I now want to calculate the new radius, I can go through the same equation, same physics, same principles, but the only change that I need to make is when I come to substitute this value for the mass. Okay, when I come to do that, instead of the mass of the proton, I must use 12 times of that. I must use 12 times of that. So this I must times 12 here, times 12 here. So my answer would end up being 12 times bigger. So instead of 1 millimeter radius that I got for the hydrogen ion, the answer is now 12 millimeters. In other words, if I shoot a carbon ion into this magnetic field, it will go round in a circle that has a radius of 12 millimeters. And you can see why from the equation, because the mass is increased by 12 times. But physically we can also understand why, because see, the force has not changed. The force only depends, if you look at the force from the magnetic field, it only depends on the magnetic flux density, the charge, and the velocity. So none of these three quantities have changed. It's just the mass that has changed, right? And the mass, if the mass has changed but the force has not, it will change the radius, because for a bigger mass with the same force, it will not bend so much. You can imagine that the mass is harder to change direction because it is more massive. So which is why it will go around in a bigger circle. A smaller circle means that it bends more easily. If it bends less easily, it will tend to go more straight. Okay, and a bigger circle, a bigger radius, just means that it goes more straight than the smaller circle. So that's how we can think of it physically.